Today we are going to talk about Cambridge IGCSE Physics 0625. First topic, motion, forces and energy. 1.1, physical quantities and measurement techniques. Supplement part 2. So we can see here the syllabus under the supplement part. Number 4, understand that a scalar quantity has magnitude only and that a vector quantity has magnitude and direction. Number 5, know that the following quantities are scalars: distance, speed, time, mass, energy, and temperature. Number 6, know that the following quantities are vectors: force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Number 7, determine by calculation or graphically the resultant of two vectors at right angles limited to forces or velocities only. So here highlighted part we are going to talk about today. So scalar quantity and vector quantity. A scalar quantity has only magnitude. Examples: length, area, volume, speed, mass, density, pressure, temperature, energy, work and power. A vector quantity has both magnitude and direction. Examples: displacement, velocity, acceleration, momentum, force, lift, drag, thrust, electric field strength, gravitational field strength, and weight. So we'll see the difference between distance and displacement. So we know distance is a scalar quantity. When you draw a line A to B, which is distance, we can see all the time it changes its direction. So displacement is a vector quantity. When you draw a line A to B directly, we can see only one direction. Resultant of two vectors. Here we are going to talk about resultant of two vectors which right angles to each other. So we'll see there is a velocity 10 meters per second to the east. There is a velocity 5 meters per second to the south. So when you draw 10 meters per second, that vector and the 5 meters per second is downward vector. Now the third side of this angle giving us the resultant. So we can see here we have made a right angle triangle. So because of that, here we can use Pythagoras theorem to find the resultant. So we know r square is equal 10 square plus 5 square. So r square is equal 100 plus 25. R square is equal 125. R is equal 125 square root. So R is equal 11.18 meters per second. That is the resultant value. Now we'll say vector diagrams. So vector diagrams are scale drawings used in physics to visualize and analyze vector quantities such as force, velocity, and displacement that have both magnitude and direction. They use arrows where the length represents magnitude and the angle indicates direction, allowing for determination of resultant vectors or components using methods like the parallelogram or tail to head triangle. We'll see the parallelogram law of vector addition. The parallelogram law of vector addition is the process of adding vectors geometrically. This law says two vectors can be arranged as adjacent sides of a parallelogram such that their tails attach with each other. The sum of the two vectors is equal to the diagonal of the parallelogram whose tail is the same as the two vectors. We'll see now, consider the vectors P and Q below to find their sum. So here we can see tail and head. How to represent this is a tail part, this is the head part. Now this is a P vector given, this is a Q vector given. We'll see the first step. Draw the vectors P and Q such that their tails touch each other. Yeah, like this way. Then step 2, complete the parallelogram drawing the other two sides. Yeah, here we do. Step 3, the diagonal of the parallelogram that has the same tail as the vectors P and Q represent the sum of the two vectors. Yeah, so we can see here P plus Q is equal to R. So head to tail triangle method we'll see. The head to tail method is a graphical technique for adding vectors by placing the tail of each subsequent vector at the tip, which means head of the previous one. The resultant vector representing the total sum is drawn from the tail of the first vector to the head of the last. Yeah. You see again, consider the vectors P and Q below to find their sum. Again, here this is the tail, this is the head of the arrow. So this is P, this is Q. We'll see the first step. Draw the vectors P and Q such that P's head touches Q's tail. This is P. His head is now touching the Q's tail. Okay. Step 2. Complete the triangle by drawing third side, which is resultant. Yeah. Now we draw the third side, that is the resultant. Step 3. The third side of the triangle, that its tail on P's tail and head on Q's head. Yeah. That means the tail of the perspective to the head of the last. Yes. As P and Q represent the sum of two vectors. Yeah. Again, we can see P plus Q is the R. So we'll see this question. State the factors which completely describe a vector quantity. Yes. Size or magnitude and direction. B part. An aeroplane is flying towards the east in a still air at 92 meters per second. Wind is start to blow at 24 meters per second towards the north. Draw vector diagram to find resultant velocity of the aeroplane. Use a scale of 1 centimeter showing 10 meters per second. So we can use our ruler. So here 92 and 24. So here this is a representation of the directions north, south, west and east. Yeah, now first of all we take our ruler and we are measuring 2.4 centimeter, which is 24 meters per second according to the scale. And to the each side we are drawing a line arrow 9.2 centimeter, which represent 92 meters per second. Now we are getting that 9.2 centimeter arrow and we keep its heads on the tail of the 2.4 centimeter arrow. Now we can complete that side by drawing the resultant. So this is the. So we can see this angle is the angle between resultant and the easterly direction. This is a right angle triangle. We can use again Pythagoras theorem, which is r square is equal 24 meters per second square plus 92 meters per second square. So r square is equal 576 m square s minus 2 plus 8,164 m square s minus 2. So r is equal 9,040 m square s minus 2, that thing's square root. So we will get r is equal to 95.07891 meters per second. So which is the resultant. And when we measure the length of the third side, you will get it is around 9.5 centimeters. So that is how to find the resultant without doing the calculation. So then we are going to find the angle between resultant and this direction. We are using here tan theta because we know this is a right angle triangle, so we can apply trigonometry here. So tan theta is equal opposite side divided by adjacent. We know opposite side is 20 meters per second divided by adjacent, it is 92 meters per second. Tan theta is equal 0.26086. So theta is equal to tan inverse of 0.26086. So we know theta is equal to 14.62, which is around 15 degree. So resultant speed is 95 meters per second. Angle between resultant and the easterly direction is around 15 degree. So figure 2.1 is a head-on view of an airliner flying at constant speed in a circular horizontal path. The center of the circle is to the left of the diagram. A part. On figure 2.1, draw the resultant force acting on the airliner and explain your answer. Yeah, so this is the resultant. So explanation for the answer is airliner accelerating no change in direction and caused by force in that direction. So we can tell it as a centripetal force. Now the B part, the weight of the airliner is 1.2 into 10 to the power 6 Newton. And there is an aerodynamic lift force of 1.39 into 10 to the power 6 Newton acting at 30 degree to the left of the vertical. By drawing a scale vector diagram or otherwise, show that the resultant of these two forces is in the same direction as the resultant force you drew in A. Okay. So this is the lift 1.39 into 10 to the power 6 Newton. And the weight is 1.20 into 10 to the power 6 Newton. So when we draw the lift like this way and weight like this way, we can make a parallelogram like this way. So its diagonal is the resultant like this way. So we know there is a vertical line and the lift is 30 degree to that. So this is the 30 degree. And the below angle also like this way 30 degree. So when we draw like this say 1.39 into 10 to the power 6 Newton and the 1.20 into 10 to the power 6 Newton according to the triangle method. So the third side we can draw as resultant like this way. Right. So this is 30 degree. So we use cosine rule to find the resultant. So the cosine rule or law of cosines is a formula used to find missing side lengths or angles in non-right angled triangles. It states a square is equal b square plus c square minus 2 into b c cos a, where a simple A is the side opposite, angle is capital A, and simple B and simple C are the adjacent sides. It is used for side angle side, we call SAS, and side SSS scenarios. So here, this is the now drawing. You can see simple A is the resultant. So opposite angle is 30 degree now. So simple B, which is the lift 1.39 to 10 to the power 6 Newton, its opposite angle is capital B. Weight 1.20 into 10 to the power 6 Newton, which is simple C, its opposite angle is capital C. Right. So we are writing now cosine rule, A square is equal to B square plus C square minus 2BC cos A. So we know B value it is 1.39 to the power 6 square and plus 1.20 into 10 to the power 6, which one's square value we are getting, minus 2 into 1.39 into 10 to the power 6 into 1.20 into 10 to the power 6 into here A. We can see angle, it is 30 degrees, so cos 30. Now when we take the 1.39 into 10 to the power 6 square value, we will get 1.9321 into 10 to the power 12 plus 1.44 into 10 to the power 12 minus 3.36 into 10 to the power 12 into cos 30, we know 0.8660. So again, A square is equal to 3.3721 into 10 to the power 12 minus 2.888976 into 10 to the power 12. So we will get A square 0.48312 to the power 12. So A square is equal 4.8312 to the power 11. So the square root of A, we are getting as A is equal 48.3124 into 10 to the power 10. So we will get A as 6.95 into 10 to the power 5 Newton. So which is the resultant value. Now again we roll it like this way. So which is there's a 30-degree angle from the vertical, and then we will get the vertical component of lift as 1.39 to the power 6 into cos 30. And we can get the horizontal component of lift as 1.39 into 10 to the power 6 Newton in sine 30. So we can calculate the value for horizontal component of lift as 1.39 into 10 to the power 6 into, sine 30 is 0.5, that means half. So 6.95 into 10 to the power 5 Newton is the horizontal component of the lift. So we know already we found resultant as 6.95 into 10 to the power 5 Newton. And we found now horizontal component of lift also 6.95 into 10 to the power 5 Newton. So both are equal to each other. That means, so the resultant is horizontal.